Welcome back, everyone. We're about to take a deep dive into something really cool, asteroid mining robots. I'm betting you've wondered how those robots can actually function in space, especially when it comes to mining those asteroids.
Right. It's a pretty amazing feat when you think about it.
For sure. And lucky for us, we've got an awesome chapter from a technical document that's going to give us the inside scoop.
We're going to be covering all sorts of things like how they move in that crazy low
How they
gravity,
even grab on to things.
and even what the future holds for these space robots. It's going to be wild.
I can't wait. So, to kick things off, could you paint us a picture of just how extreme the environment is for these robots out there mining asteroids? What are the biggest challenges they face?
Well, just imagine an environment that's almost the opposite of what we're used to here on
Oh,
Earth.
okay, I'm all ears.
First off, you've got this insanely low gravity. I mean, seriously low.
So, like, everything's just floating around.
Pretty much. The robots themselves, the tools, even the materials they're trying to mine, it's a constant challenge to keep things from just drifting away.
Wow, I can already see how that would make things tricky.
And it's not just the low gravity. Asteroids themselves aren't these nice, perfect spheres.
Yeah, you always see those in the movies.
Right. But in reality, they're all lumpy and bumpy with unpredictable surfaces.
So, it's like a giant space obstacle course for these robots.
You got it. And then throw in communication delays. Remember, we're talking deep space here. Signals can take a really long time to travel back and forth to Earth.
So, no joystick-controlled robots then? No quick commands?
Nope. These robots have to be incredibly smart. They need to be able to make decisions on their own, adapt to changing situations. We call it autonomy.
So they're basically like little robotic explorers figuring things out on their own, millions of miles away.
Exactly. And all while trying to conserve energy. Solar power is precious out there, so efficiency is everything.
Every watt counts, huh?
Absolutely. All right, so we've got this super challenging environment, low gravity, unpredictable terrain, communication delays, limited power. How in the world do these robots actually move around out there?
Yeah, that's what I'm wondering. It's not like they can just walk or drive like they would here.
Well, engineers have come up with some seriously creative solutions. One approach is using tethered systems.
Tethered, so they're basically attached to something.
Yep, it's like a safety line, keeping the robot from drifting off into the abyss.
Makes sense. Kind of like a space leash.
You could say that.
Yeah.
But tethers only work for so long. For longer distances, you need other solutions. That's where things get even more interesting.
Okay, I'm intrigued. Tell me more.
Well, some robots are actually designed with legs, and some even hop.
Hopping robots. Are you serious?
Oh yeah, totally serious. It might sound strange, but it's actually a super efficient way to get around in that low gravity.
It's like a little robotic bunny hopping across an asteroid.
Exactly. The European Space Agency even sent a hopping robot called Mascot to explore the asteroid Ryugu.
That's amazing. So are hopping robots the best solution then for every situation?
They're great for some things, but not everything. For smoother areas, we also use robots with wheels and tracks, kind of like what you'd see on a rover here on Earth.
But I bet those wouldn't work so well on loose, rocky terrain, right?
You're exactly right, they just spin out. So for maneuvering in that low gravity, engineers have turned to physics.
Okay, now we're getting technical. How so?
They use things called reaction wheels and thrusters.
That sounds familiar.
Reaction wheels are kind of like internal spinning devices. By controlling their speed and direction, we can actually rotate the robot. It's a bit like a figure skater, using their arms to spin faster or slower.
Okay, I think I get that. And what about thrusters?
Those are like tiny little rockets that use small bursts of gas to push the robot in different directions.
So it's all about controlling these tiny forces to move around in that weightless environment. Pretty clever. But asteroids aren't exactly predictable, are they? What happens when a robot encounters something unexpected?
That's the real challenge. But engineers have thought of that too. One solution that's getting a lot of attention is shape-shifting robots.
Hold on, did you say shape-shifting? Like Transformers?
Pretty much. Imagine robots that can fold themselves into different configurations, changing their shape to adapt to the terrain.
That sounds straight out of science fiction, but it's real.
Oh, it's real. NASA, for example, has developed these robots called puffer robots. They can squeeze into tight spaces, navigate obstacles. It's incredible.
Wow, so they're like robotic origami.
Exactly.
Yeah.
We also have climbing and anchoring systems for robots. Imagine things like harpoons, drills, or even magnetic feet that can grip onto the asteroid surface.
So they're ready for anything.
As ready as we can make them. And remember those hopping robots we talked about? They're not just for fun.
I was wondering about that.
Hopping is a super efficient way to cover ground, especially in low gravity. It's also great for overcoming obstacles.
So it's all about conserving energy and making every movement count.
Exactly. Okay, so we've covered how these robots move around in this crazy environment. But how do they actually interact with the asteroids? What tools do they use?
Yeah, I'm curious about that too. How do they pick things up, dig, all that?
Well, one technique they use might surprise you. It's called electrostatic adhesion.
Electro what? That sounds complicated.
It sounds fancy, but it's actually a pretty simple concept. Think about static cling like when a balloon sticks to your hair.
Ah, okay, I get that.
Well, we're using that same principle in space. The robots use electrostatic forces to pick up tiny bits of material from the asteroid's surface. And it works even better in a vacuum.
So they're basically using static cling to mine asteroids.
You got it.
Hmm,
It's a really effective way to collect samples. But we also use more traditional tools like drills to dig in and grab bigger pieces.
makes sense. Those are pretty essential for any kind of mining operation, I imagine.
Exactly. And then there's another really cool tool inspired by nature gecko-inspired grippers.
Gecko inspired, like those little lizards that can climb walls.
Yep, those are the ones. These grippers use the same principles that allow geckos to stick to surfaces, giving robots the ability to grip onto all sorts of things.
Wow, that's incredible. Nature really is the best engineer.
Absolutely. Nature has already solved so many problems that we're still figuring out. Okay, so we talked about how they move and the tools they use, but how do they actually excavate the materials? And what about handling all that stuff in low gravity? Doesn't it just float away?
Yeah, I imagine things could get pretty chaotic.
It's definitely a challenge. But like I said, engineers are incredibly clever. One method for digging deep is using specialized drill systems.
So they're not just scratching the surface.
Nope, these drills can bore deep into the asteroid. The OSIRIS-REx mission, for example, used a robotic arm with a drill that created a mini explosion with nitrogen gas to collect material from the asteroid Bennu.
A mini explosion. That sounds intense.
It was, but it worked. For larger scale excavation, there are also bucket wheel excavators, like scaled-down versions of those massive mining machines you see on Earth.
So they're bringing Earth-style mining to space.
In a way, yes. But everything has to be adapted for that low-gravity environment. And for really tough materials, they use percussive hammers that vibrate to break things up.
So drills, scoops, hammers, it's a whole orchestra of space mining going on out there.
It really is. Now, to answer your question about handling all that material in low gravity, that's where things get even trickier. We have to use specialized systems to move and manage everything.
Like what?
One solution is using conveyor systems, which are like robotic arms or belts that transport the material. But even these systems need to be carefully stabilized to prevent them from swinging around in that low gravity.
Yeah, I can imagine that.
For metallic particles, magnetic collectors can gather and contain them. And for loose material, we use pneumatic systems, which basically use airflow to move things around in a sealed environment.
Wow, it sounds like they've really thought of everything. But all this fancy equipment is useless without a brain to control it, right? How do these robots make decisions in such a complex and unpredictable environment?
You're absolutely right. That's where artificial intelligence, or AI, comes in. These robots are equipped with a ton of sensors and algorithms that allow them to perceive their surroundings, plan their actions, and make decisions on the fly.
So these robots are packing some serious brain power.
Absolutely. They have to be smart. Machine learning and AI are essential for them to operate autonomously and adapt to the ever-changing conditions out in space.
It's mind-blowing to think that they're learning and problem-solving on their own,
Well,
billions of miles away from us. What kind of sensors are we talking about here? What are they using to see and feel their surroundings?
they've got a whole suite of amazing sensors. LiDAR and cameras allow them to create detailed 3D maps of the asteroid's surface, which they use for navigation. Spectrometers help analyze the composition of the surface to guide mining operations. And then there are force and torque sensors, which constantly monitor interaction forces to make sure the robots maintain their grip during delicate tasks.
So they can see, feel, and even analyze the environment in ways we can't. That's incredible.
It is. But we're not stopping there. We're also exploring a really fascinating concept called swarm robotics.
So robotics. That sounds intriguing. What is that all about?
Imagine multiple robots working together as a team. like a colony of ants or a swarm of bees. They share information, adapt to changes collectively, and work together to make the whole mining operation even more efficient.
It's like a well-coordinated robotic ballet out in space.
Exactly. And all of it made possible by those incredible sensors and AI we were talking about.
This is all so amazing. Are there any real-world examples of these robots in action, or is this mostly still theoretical?
Oh, we have real-world examples. Remember that hopping robot we mentioned, Mascot, the one that explored asteroid Ryugu? That's a perfect example. And then there's the OSIRIS-REx mission, which used a robotic arm called TAGSAM to collect samples from the asteroid Bennu. It even used AI to navigate and avoid obstacles.
Wow, so these robots are actually out there doing this right now. Incredible.
And this is just the beginning. The future of space robotics is even more exciting, with even crazier ideas and possibilities on the horizon. We'll delve into that next.
I can't wait. This deep dive has been an incredible journey so far. But before we jump into the future, I want to take a step back and look at the bigger picture. These robots are incredible, but they're not operating in a vacuum, right?
You're right. Behind every successful robot is a team of brilliant minds, engineers, scientists, and technicians who are constantly pushing the boundaries of what's possible.
So it's not just about the robots themselves, it's about the human ingenuity and collaboration that make it all happen.
Absolutely. And as we venture further into space, that partnership between humans and robots will only become more crucial.
So it's not just about the tech, it's about the people behind the tech. I love that. And speaking of different environments, space isn't exactly a one-size-fits-all kind of place, is it?
You're telling me.
Yeah.
Every planet, every moon, every asteroid is a whole new ballgame.
So how do these robots adapt to those diverse challenges? I guess that's what we'll explore next, right?
Exactly. Buckle up, because it's about to get even more fascinating.
So many different worlds to explore, each with its own set of challenges. What are some of the specific hurdles these robots face on other celestial bodies, like the moon or Mars?
We'll take the moon, for instance. It's got its own gravity, obviously, but it's still way less than what we're used to here on Earth, about 1/6.
So while robots don't have to worry about drifting off into space quite as much, there are still some gravity-related issues to deal with.
Oh, absolutely. Traction is a big one. It's harder for robots to get a good grip on the lunar surface, and they're more prone to tipping over because of that lower center of gravity.
Interesting. So even on the moon, robotic movement isn't as straightforward as it might seem.
Not at all. And then you've got Mars. Talk about a challenging environment.
What makes Mars so tough for robots?
Well, for starters, the atmosphere is super thin, which affects things like aerodynamics and temperature control.
Right, Mars can get pretty chilly, can it?
You bet. Those robots have to be able to withstand some seriously freezing temperatures. And then there's the dust.
Ah, yes, Martian dust. I've heard that's a real problem for robots.
It's a major headache. The dust is incredibly fine and abrasive, and it gets into everything.
So robots on Mars need to be built tough and dust-proof.
You got it. They need to be able to withstand the elements, maintain their functionality, and keep on exploring. It's a tall order.
It sounds like it. It's amazing how engineers have to adapt robotic designs for each unique destination. We were talking about asteroids earlier. What are some of the specific environmental factors that make those so tricky?
Well, besides that crazy low gravity, which we already discussed, asteroids can also spin, sometimes really fast.
Really?
Huh?
Wow, I hadn't thought about that. I can only imagine what that would do to a robot trying to stay on the surface.
It's a wild ride for sure.
Sure.
And those hopping robots we talked about, those come in pretty handy in those situations. Or tethers.
Yeah, I can see how those would be lifesavers, literally. Anything else that makes asteroids unique?
Their composition. Asteroids can be made up of all sorts of things: rock, metal, ice, even organic compounds.
So it's not just about designing robots that can move around. They also need to be equipped to analyze and interact with all those different materials.
Exactly. It's all about adaptability and versatility. The engineers have to think about everything: the environment, the mission objectives, the limits of our technology.
They've got their work cut out for them, that's for sure. Speaking of challenges, what would you say are some of the biggest hurdles engineers are facing in space robotics right now? What are the things that keep them up at night?
One of the biggest challenges, and it's only going to get tougher, is developing robots with even greater autonomy. The further we travel into space, the longer those communication delays become.
Right, we talked about that earlier. So basically, we need robots that are even smarter and more independent.
Exactly. We need robots that can make complex decisions on their own, handle unexpected situations, learn from their experiences, all without humans having to step in.
It sounds like AI and machine learning are going to be even more critical in the future of space exploration.
Absolutely. Those are the technologies that are going to allow us to send robots further and deeper into space, to places where humans can't yet go. Another big challenge, and this is always going to be an issue, is power.
Right. We talked about how limited solar power is in deep space. Are there any other potential solutions on the horizon?
Researchers are exploring a lot of different avenues. Nuclear power is one option, especially for emissions further out in the solar system where sunlight is weaker.
Yeah.
But that comes with its own set of challenges, of course. And then there's some really cool ideas around energy harvesting.
Energy harvesting, what's that?
Basically, it's about finding ways to generate power from the environment itself, like using the robot's own motion to generate electricity, or harnessing temperature differences in space.
Wow, so it's like turning the environment into a giant battery.
Exactly. It's still early days, but there's a lot of potential there. We're always looking for ways to make these robots more self-sufficient and less reliant on us for power.
Makes sense. What about materials? Are there any big leaps happening in materials science that are relevant to space robotics?
Absolutely. Material science is a critical part of this whole field.
Hmm.
We're always striving to develop lighter, more durable, and more radiation-resistant materials.
Lighter materials are important, right, to keep the weight of the spacecraft down.
Every ounce counts when you're launching something into space.
Yeah.
So finding materials that are both lightweight and strong enough to withstand the rigors of space travel is essential. So yeah, material science is a huge part of making all this possible.
It's incredible how everything is interconnected. So we've talked about the challenges, but let's shift gears a bit and talk about the potential benefits of all this. Why are we going through all this trouble to send robots to mine asteroids? What makes it worthwhile?
The potential rewards are enormous. I mean, think about it. Asteroids are packed with valuable resources.
Right, we're talking about things like metals and minerals, right?
Exactly. Metals like platinum, gold, iron ore, essential for our industries here on Earth. But asteroids also contain water, which could be used for life support or even broken down into hydrogen and oxygen for fuel.
So we could create these cosmic gas stations and supply depots in space using the resources we find out there.
Exactly. It would be a game changer for space exploration. Imagine not having to launch everything we need from Earth, which is incredibly expensive and resource intensive. We could actually start building and expanding our presence in space using materials we find out there.
That makes a lot of sense. Are there other benefits beyond just fuel and building materials?
Some scientists believe that asteroid mining could help us unlock secrets about the origins of our solar system.
Really? How so?
Well, by studying the composition of asteroids, we can learn a lot about the conditions that existed billions of years ago when our solar system was just forming. It's like looking back in time.
Wow, that's incredible. So not only could these robots help us expand into space, but they could also help us understand our place in the universe.
It's a win-win. And let's not forget about the economic impact. Asteroid mining has the potential to be a trillion-dollar industry. We're talking about creating entirely new industries and generating a ton of wealth. It's going to reshape our world in ways we can't even imagine.
Wow. It's almost too much to take in. A trillion-dollar industry, a key to understanding our origins, the fuel for further space exploration. It's mind-blowing.
And we haven't even touched on the geopolitical implications. Whoever controls these resources will have a huge advantage in the future. It's a whole new landscape for international relations.
So asteroid mining, it isn't just about science and technology, it's about power and economics too.
Exactly. It's a game changer on a global scale. But it's important to remember that we're still in the very early stages. There are many challenges ahead, both technical and ethical, but the potential rewards are so great that it's definitely worth the effort. Who knows what incredible discoveries await us out there? It's an exciting time to be alive, that's for sure.
It certainly is. This deep dive has been fascinating. We've covered so much ground, from the nitty-gritty technical details to the broader implications for humanity. But there's one more aspect I want to explore, the human element. These robots are incredible, but they're not operating on their own, are they? There are people behind the scenes making all this possible, right?
You're absolutely right. Behind every successful robot is a team of brilliant minds, engineers, scientists, technicians, all working together to push the boundaries of what's possible. They're the unsung heroes of space exploration.
It's easy to get caught up in the technology and forget about the human ingenuity that makes it all happen. So let's dive into that human side of things. How do we actually control and interact with these robots when they're millions of miles away?
Yeah, it's almost like we're living in a sci-fi movie, but it's real life. So walk me through this. How do we actually control these robots when they're so far away? Is it like in those movies where someone's sitting at a joystick, maneuvering them in real time? I wish it were that simple. But unfortunately, those communication delays we keep talking about,
Yeah.
they always kind of make real-time control impossible.
Right, that makes sense. Space is vast. So how does it actually work? If we can't control them directly, how do we make sure these robots are doing what we want them to do?
It's a combination of a lot of planning beforehand and some pretty sophisticated systems that let the robots operate on their own. Before a mission even launches, engineers spend an incredible amount of time developing really detailed plans and algorithms. It's like a script, but for a robot.
So they're given their instructions and then they're off on their own, like little robotic explorers.
Yeah, pretty much.
Yeah.
But we're not totally hands-off. We're constantly monitoring their progress, receiving data and images they send back,
Even with those delays.
even with the delays. We have to be patient, but it's worth it. And if we need to, we can send them updated instructions or make changes to the mission plan based on what we're seeing.
So it's kind of a back and forth, even over those vast distances. Amazing.
It is. And as AI and machine learning get even better, these robots will become more and more autonomous. They'll be able to handle even more complex tasks and make decisions in real time without us needing to micromanage them.
It's almost like we're giving them a little piece of our own intelligence, sending it out to explore the universe for us.
That's a great way to put it. But it's not just about programming and monitoring. There's a whole other side to the human element of space robotics.
Oh, tell me more.
Well, once those robots start sending back data, someone has to make sense of it all.
Right, all those images, sensor readings, and whatnot. It's not like they come with a handy translation guide.
Exactly. So we have teams of scientists and engineers who spend their days, sometimes even years, poring over all that data, trying to understand what it all means.
That sounds like a pretty amazing job. To be the first to see those images from another world, to uncover secrets hidden in the data. It must be thrilling.
It definitely has its moments. Every mission brings new discoveries, new challenges, and new insights into the universe. And beyond analyzing the data, there's the constant work of developing and improving the robots themselves.
So it's a never-ending cycle of innovation and exploration.
Exactly. Every mission teaches us something new, shows us where we can improve, and inspires us to push the boundaries even further. So what are we working on now?
Yeah, what's next for space robots?
Well, there's a lot of excitement around bio-inspired robotics.
Bio-inspired, like robots that take cues from nature.
You got it. Nature has had millions of years to perfect its design, so why not learn from the best? We're talking about robots that slither like snakes, climb like geckos, swim like fish.
Wow, that's amazing. I mean, think about how a snake can move through tight spaces, or a gecko can cling to almost any surface.
Exactly. Those are capabilities we want our robots to have, especially when we're exploring environments like caves on Mars or the icy moons of Jupiter.
So, nature is providing a whole new toolbox for space exploration. What about AI? Where does that fit into the future of space robotics?
AI is going to be absolutely essential. As robots become more autonomous, they'll need even more advanced AI systems to help them navigate, make decisions, and even cooperate with each other.
So we're talking about robots that can learn, adapt, and maybe even repair themselves.
Exactly. Robots that are more like partners in exploration, not just tools. And that will allow human astronauts to focus on things that require our unique abilities, like scientific research and creative problem solving.
It's a pretty incredible partnership when you think about it. We're sending these robots out as our emissaries to explore the cosmos and bring back knowledge and resources that will benefit all of humanity.
And that's really what it's all about, isn't it? Pushing the boundaries of what's possible, expanding our understanding of the universe, and securing our future as a spacefaring species.
Beautifully said. And it wouldn't be possible without the incredible work of engineers, scientists, and technicians all over the world.
A massive collaborative effort. Really inspiring.
It really is. So to all of you listening out there, keep looking up at the stars, keep asking questions, and never stop exploring the wonders of space. Who knows what amazing discoveries await us in the years to come. Thanks for joining us on this deep dive into the world of asteroid mining robots. Until next time.